Hi, we're going to go over the marker board problems that we did in class today. This is over 1.2, and we talked about what makes a table a function and what makes a table not a function, and we compared it to a vending machine where in table 1, when I push a 5 and I get out a 1, that means every time I push a 5, I should get out a 1. So here I push a 5, I get out a 0. This is not a function, not only for the vending machine, but for the definition. For every x, there is only one y. Usually I say for every x there is one and only one y, you get what I mean. So for every x, so for this when x is 5, there should only be one corresponding y, not two. So that's why this is not a function. There's nothing wrong with table 2. When x is 5, y is 1. Push 5 again, you still get out a 1. That is a function. This next one, no matter what, every time you push 5, you're getting something completely different. On this side, it's okay to have these 5s because this is similar to a vending machine that only puts out water bottles. You push a 2, you get out a 5. Push a 3, you get out a 5. 1, you get out a 5. Basically, this table only makes 5s. No matter what x you put in, it only puts out a 5. So this one is a function. This one is not. Okay, for this one, once again, table A or table 1 is basically, this one's a weird one, and I made it without thinking, but really it's just representing 1 point, 2, 1. It's tough to be a function when you're just 1 point. This one, each time you push 1, you're getting a different output, which is not acceptable. It's not functioning. It's not a function. Okay, table 1, we're looking good, except for when I push a 1, I'm getting out a 1. This time when I push a 1, I'm getting out a 4. So every x can only match up with one y, so this is not a function. Nope, not a function. This one, fine. Once again, every x that we push, we're getting out the same output, but that's okay. There's still only one y that matches up to x. When x is 1, y is only 2. There's not another number that y can be when x is 1. So yes, this is a function. Okay, and then when we're looking at graphs to tell whether something's a function or not, we're just using the vertical line test. And so we would throw the line, which, yep, it went under. I'm going to fix the line real quickly. Okay, so if we go ahead and pass the vertical line over the graph, we can see that it only hits the graph at 1 point at a time. So yes, this is a function. Our next graph, we can recognize that it's a quadratic, and we know quadratics are functions, but we can also use our vertical line test to see as the vertical line is moving, it is only hitting 1 point at a time. That's another way to show that it is a function. This one looks like a sideways quadratic, but it is not a quadratic. And you can tell real easily when you roll the vertical line over it that it is hitting 2 points. It's hitting 2 points each time you're moving it, which that's not a function. If you want to think about it further, it's kind of like this. If we look at when x is 2, okay, when x is 2, the y's that match up with that, there are 2 of them. When x is 2, y looks to be either about, I don't know, let's see, that's a 3, so that's 2 point something, let's see, this is 32, let's just say it's 2.4, and then it also matches up with, when x is 2, it matches up to this y, which looks like it's, no, we're just going to say negative 2.8. And that's another way to tell that it's not a table, because that's another way to tell it's not a function. Because if you put it in the table, when x is 2, it would match up with two completely different y's. No, it is not a function. No, either way. Okay, and our last one, if you put the vertical line over our vertical line, put the vertical line over the vertical line, and you can see that beep, 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 tons and tons of points are being intersected. No, it is not a function. So in this case, x equals 2.5. The line x equals 2.5 is not a function. Okay, function or not. Basically, with this, we're recognizing that it is a quadratic. There are no exponents greater than 2, and we know that quadratics are functions. So yes, this is a function. This next one, we can see that it's going to also be a quadratic because we see the x squared. But if you wanted to, you could go ahead and try to isolate y. You can go ahead and add 5x to both sides. Plus 2x. And you can even go ahead and divide every term by 3. And then you can really tell, oh yeah, this is a quadratic. Yes, it is a function. It's okay to take the time to go ahead and isolate y just to double check. It's also okay to look at this and go, I can tell it's a quadratic just looking at the original equation. Okay, this next one, this right here is our warning sign. It's our warning sign that this is not going to be a function. If y is squared, when we solve for y, taking square root of both sides, we saw in class that that's going to give us 2 values of y for every one x, and that's not a function. So no, be on the lookout for that. Okay, and this is where we are using function notation. When you see f of x, we call that function notation. And basically to find f of 4, you are taking the x out as if you could just take it and just like throw it out. And in its place, you're replacing the 4. And the minus stays the same and the 7 stays the same. And so then you go ahead, 3 times 4 is 12, 12 minus 7 is 5. So function notation tells us what to put in for x, and then to go ahead and solve it. Okay, so here, instead of plugging a number in, we're going to plug in x plus h. So that means when we see a 3, we see a 3. We write a 3. When we see an x, we're going to throw it out. And instead of writing an x, we're going to write x plus h minus 7. We can leave it like that, or we could take the time to distribute. Distributing doesn't reward us in any way. It is actually better off in the factored form. I'll accept either one if that was a test question. All right, this is called a piecewise function, where there are 2 possibilities depending on what x is. And so when this asks us to find f of 6, I know that 6 is greater than or equal to 2. So therefore, I'm going to go ahead and follow this rule. So I'm going to take x is 6. I'm going to plug in 6 for x. And I'm going to go ahead and 24 minus 3 is 21. So depending on what your x is, that's how you can decide which rule to use, either the 4x minus 3 rule or the 5x rule. This next one, it says find f of 2. So I'm looking, if my x is 2, I know I can't use this one because this says if x is less than 2. Well, 2 is not less than 2, so I can't use that one. So I'm going to keep going. It's this one. 2 is definitely greater than or less than 2. So that means that I use this rule. Plug the 2 in for x. So I'll have 4 times 2 is 8 minus 3 equals 5. And wonder if x is equal to -1. So I'm going to find out which rule to use. Let's see. This one says x is less than 2. -1 is less than 2. So that means that I'm going to use this rule. So I'll plug in -1 for x, and I'll get -5 as my answer. Find the domain of this function. Basically, when they're asking us this, they're saying, what numbers can I plug in for x that will give me a y that is a real number? And remember, we talked about in class that real numbers are any number that is on the number line, whose home is the number line. So those are all the numbers we've been working with except for imaginary. And so when we look at this, we notice there are no trouble. There's no trouble points, trouble spots. There are no square roots. There are no denominators. And so this is a case where we can plug in any real number for x, any number at all. And so if I were to translate that to a number line, basically it's saying I can plug in any number on the number line all the way from -infinity to +infinity. And so I'm going to go ahead and say just that, from -infinity to +infinity, that we just leave it as a infinity. We don't need to put the plus ahead of it. That describes what's going on here. Any x in the number line. The old way, you used to say all real numbers. Well, now this is the way that we do interval notation that says the same thing. Once again, we use parentheses when we can't include something, and we can't include our infinities because they are concepts, not a number. Okay, this next one, there's trouble. When we see that we have a denominator and they're asking us, hey, what numbers will work for x to give y, to make y be a real answer, an answer that is a real number on the number line? Well, we know right away that our denominator cannot equal 0. Because if our denominator equals 0, then this fraction is going to be undefined. And there's not an undefined on the number line. So we're going to go ahead and solve for x. I'm going to solve with, instead of the equal sign, the not equal sign, but I think you guys can follow that. Okay, so it's saying, hey, x can't equal 1/4. You know why? Because when you take 1/4 and you plug it in, you're going to get 4 times 1/4 is 1, and 1 minus 1 is 0. So we can't have x be 1/4. X can be anything else it wants to be. It just can't be 1/4. And so I'm going to take, once I solve, I'm going to go ahead and take that info and draw my number line. So I'm going to put a 1/4. Whoops. I'm going to put a 1/4. And guess what? It cannot be equal to 1/4, so I'm going to put an open circle here, indicating that the solution does not include 1/4. But x can be anything it wants on this side, and x can be anything it wants on this side. If we take any of those x values and plug them in to this equation, we will get a y that's a real number. So how do we express this number line in interval notation? Well, this side, we're going to say is from -infinity to 1/4. We're putting a parenthesis around the 1/4 because we're not including it. It's definitely, if we include it, we just got a undefined y. And then we're going to use the upside down U to indicate and, because we have a second part of our answer. The second part of our answer is from 1/4 to +infinity. All right, we have trouble right here. Because we have a square root, we have to be very careful with what we do underneath the square root. So we're going to look at x plus 4, and we're going to remember, oh, that's right, it has to be greater than or equal to 0. Whatever is underneath the radical sign has to be greater than or equal to 0. If it's less than 0, then we end up with y being an imaginary number. Imaginary numbers do not reside on the number line. That's only for real numbers. So we have to make sure that x plus 4 is greater than or equal to 0. How can we make sure? Well, we go ahead and solve for x. So we subtract 4 on both sides, and it tells us, oh yeah, x has got to be greater than or equal to -4 to make sure that this gives us a real number for y. So we're going to take our inequality and we're going to graph it on the number line. When I look at it, it says x has to be greater than or equal to -4. So since it can be equal to -4, I fill in the dot there, and greater than is to the right. And now I'm going to use my number line and go ahead and write that in interval notation. Can it be equal to -4? Yes. If we are including -4 in our solution, then we're using brackets because brackets include u. Okay, imagine, imagine there are little arrows or little fingers, and it goes all the way to infinity, which we have to use parentheses because we cannot catch infinity and include it. And that's it. I hope you have fun doing your homework, and I look forward to seeing you back in class. Thanks for watching.